I'm Olivia, and today, using Python, Jupyter Notebook, and the TomTom Maps APIs, we'll be creating a sample application to see if taxi drivers take the fastest routes. I'll start off by getting us familiar with the Jupyter Notebook environment, importing some basic Python libraries, and instantiating a basic TomTom map. From there, using sample taxi trip data, we'll calculate the average differences between the fastest routes calculated by the TomTom Routing API and the trips in our sample data. We'll be able to do some basic visualization to spot the average differences between the two types of routes.
So today on Devisode 17, we are doing our tutorial on do taxi drivers take the fastest route, which is actually a little bit of a statistics and Python tutorial already on the blog, which we see here, which is the do taxi drivers take the fastest route, which uses Jupyter Labs, which we'll be working with today. But the point of this tutorial is to essentially take an Excel file that has a bunch of different taxi trips in it and compare it to the routes that would be created from the same points using the routing API, and then to really spot the difference between the routes, saying, hey, our taxi drivers may be taking a little bit of advantage and going on longer routes maybe, or are they actually following the fastest route from point to point? So here, the one thing that's not in the tutorial is really sort of the background on Jupyter Lab, which is something I want to go over. And this is a screenshot because this is something I had to go and find because I really hadn't used Jupyter before, and just how to set up Jupyter and how to start working with it, and how to run it in the terminal here, and then opening it in your browser. And some of the first things to have set up here is, if you haven't worked with it before, that I had to go and do is make sure that you have the right version of Python installed, make sure you have Python installed, and then check the version of Python you have in your terminal. There's also a terminal on the Jupyter site directly, and sometimes if there's a discrepancy, you can check it and make sure that your environment that you're using is running the same version of Python that you want it to be for whatever tutorial you're following, if it's this one or another one. And then to install any of the libraries, which don't run immediately. So when I ran some of these libraries from the tutorial, I hadn't necessarily done a lot of work with Python, and I had to go in and sort of do a manual install through the terminal for a good amount of them because the imports didn't necessarily bring in those libraries when I would start running the code. And it was pretty easy to go and search them and to just import them directly or install them directly. But a few that I had to, that are mentioned or that I had to go install are listed here, which we rely a lot on during the tutorial, which is like Pandas, NumPy, Folium, Matplotlib. Folium is a big one because that's how we'll manage some of the map visualization.
Folium is like map visualization, and I think it's based on JavaScript still as a library.
We can go see actually, because I do have it. I have Folium pulled up here. So Folium, which is actually what I was going to chat about, works with Leaflet JS. And so this is the quick bit on Folium. If you want to read more about it. But yeah, it basically is a little bit of a map visualization specifically for Python code. And it works with, I think, most of the major map visualizations as well. And that's actually a fun one that is good to mention at this point too. So then after that, I'll go through a little bit of the sections of what I'll be doing. So even though this is step 3, the first 2 steps are installing the libraries and then getting your API key. So assuming that you have an API key, the first step that we'll do is we'll actually just set up the basic map. This looks a little bit different than it does in some of the JavaScript tutorials because you see we have this Folium section that's actually doing, that's sort of building this map display, and then we go ahead and initialize it down here. It doesn't look totally different, and I think the nice thing about Python is it's very readable. You can see what we're passing in here, how it comes down, the zoom that we're setting, the tiles, referencing the map as TomTom, returning it, and then actually displaying the map out.
I see clearly here the maps URL is exactly a format that we use in our Maps APIs. That means there's the representation of the tiles, so it's quite easy, I see.
Yeah, and that's the one thing that I like about Python is that I think if you jump in straight to JavaScript, sometime, you see this link and you don't really know what's happening, but actually some of the advantage here is that, if anything, I think it explains a little bit better to the naked eye on what's actually going on. So that's the basic map setup. Then we'll go ahead and use the routing API. You'll see me write all of this code, but this is sort of the quick bit of this is, going through and actually querying the map and things like that. And then the last part is that hopefully if we get far enough, these are some of the visualizations we see at the end, actually. which is grouping some of the delays that we see, which can be due to different reasons, but really mapping and saying, hey, where are some of these routes closest to the original and where are they not? Which you can see, which I think looks really interesting, especially with the layout. And then I like sort of the clustering here where you can see them in different areas, and then of course along the route here.
So let me see if I understand. You have obtained a CSV file that contains all the routes of taxi driving around a specific area. In this case, this is in Sao Paulo?
It's Porto. It's Porto, yeah.
Portugal,
Yes.
yes. Okay. Okay, and after that, then you can check. We can reconstruct the routes using the routing API, and then we display them. We can see, okay, if we take certain route now, these taxi drivers, how much percentage actually deviate from the optimal route, yes or no?
Exactly. Cool. So then we can probably dive right in. The first step, which is the step I'm skipping out on actually typing by hand, is just importing all of the libraries. Some of I had to add in and things like that because it's not really focused on the logic. What you can see here is you actually start to display out the information from the CSV. So we can actually open that CSV and you can actually see the data table here. Anyway, so in here you can actually see there's a trip ID. This data set clearly used to be longer because originally in the stats, I think there were it seemed to be several 100,000 trips stored. Here we see it's like there's only 320 rows, but that's basically the amount of data we're working with. So it's about 300-ish taxi trips, right? And what we can actually do here, which is something pretty simple to do, is we can go ahead and set our degrees of freedom.
What are those?
That's something used in statistics to really just tell us how many individual elements that we're going to be working with. And so we have 327 trips with 9 columns, and then we can go ahead and run that. And then it just returns itself back because we're just setting that for the stats. But then we go here, and I have already sort of like preloaded some of this map initialization because it's a little bit easier to see it than to go through and type some of the URL, because it's also something we've done on the stream before. But using the API key that we use on the stream, we'll actually go and instantiate our TomTom map here. And then if you go down here, we actually just see the map. It doesn't have any information on it, but we see it, and we do see it centered in Porto, actually, if we zoom out a little bit.
Okay.
Which is nice. So we see just the basic map, and again, it doesn't have a polyline on it or anything, but already immediately, I do like the format of this because you can run cell by cell, and we do just have this module that runs the map directly.
Yeah. As you can see, you were using the raster version of the map style. Yeah.
I want to hazard a guess that that's for Folium, because I also noticed that there's the leaflet link in here, and that this also references the leaflet JavaScript in here. Now what we're going to actually go ahead and do is try and build some of these polylines. And so what we're going to go ahead and do is we have a trip. We're going to go ahead and set it. We're going to work with the JSON because we have the polyline passed in here. In writing this, I've misspelled polyline so many times. It's pretty cool. It's deceptively hard to spell. And then we're going to get a list of coordinates. Reversed. Fetch our coordinates. And then we're going to go ahead and do a little bit of a loop here. In trip. Again, this is super readable, which I really like. And then we're going to go ahead and return that list so we can use it to draw our polylines. Then we can go ahead and plot. Going to go back to our polyline. List. Have that degrees of freedom again. And then we're going to use Folium here again. Add 2. And this is when we're going to start instantiating the map here. And then place the map yet again. We double check because it was that handy polyline the capital L that used to give me trouble. So let's see. So that's actually the first visualization that we see.
That's the first
Of one of the coordinates, yeah, of one of the basically items we can see between two of the coordinate sets.
Now, I'm assuming those are location based on the GPS from the taxi.
Exactly, yeah. So we actually have here
it's,
like
it's not really a route.
Yeah, so the polyline to list function transforms the raw polyline. So we're actually just, we're just getting that information back. And then we see it displayed out here. So this is just our first interaction of like drawing the polyline on the map. I'm going to go ahead and actually go to where we call the routing API and focus on that, because you can always go through and look up more about the Unix time conversion and things like that as well. So here, I'm just going to set the beginning and end coordinates that we're going to be working with. So I'm going to be doing a little bit more with this coordinates list. Oh, we don't want the fancy bracket. We want the normal bracket. And that's getting our origin coordinate from the trip. And we're going to go ahead and set the last one.
Yeah. So lat one and long one is where the trip begins. And the last one, lat two, is where the trip ends.
Yeah, and then you see it there. And so these are just the beginning and end coordinates that we're setting. And then here, this is down where we build the URL for the routing API, which I have set here. And we have the supporting points set up here to add in. And then I'm going to go ahead and add some if statements to help us support the taxi route here. So if we have a route, assumingly we will always have a route, or hopefully we have a route if we're trying to route with it. Support points. Using this polyline to list again. So we're going to get some of those polylines. Oh. So now we're just building the supporting points here. And this is a fun one to format, and this is where I think the Python gets kind of tricky, is that we have the latitude. We have to set it. Oh wait, hold on. We need to build the latitude like this.
This is inside Jupyter, right? Of course.
Yeah. And so the one caveat
inside Jupyter.
Yeah, the one caveat with Jupyter is, of course, that while it does autosave live, if I were to just go ahead and delete everything, there's no recovering from it if I didn't go ahead and export it, at least as far as I've interacted with it. I'm sure there are other ways to go about it. And then here, so we have that. And then using the all-important indentation, we're going to go ahead and put an else. And I think the other thing that we're not used to seeing so much on the stream is the real need to really watch the indentation, because in Python it's kind of a live or die.
It's everything, in my opinion.
Sorry?
It's everything.
Everything in Python is live or die, do you mean?
No, it's the indentation. I think it's a big paradigm that I have to switch in our minds.
Yeah, true. And I'm going to go ahead and comment here. So here we're using use the whole polyline. And then here, else we're just going to use the final coordinate. And then we're going to have another for, we're just going to actually take this, borrow it down here. We have supporting points. And then the only thing we're going to actually go ahead and change is that this becomes support points. Yeah. And then support points.
Yeah. So one, yes.
And then we're going to go ahead and move down to the bit, I have it sectioned out here, where we actually send the call to the TomTom API.
Meaning creating the route?
Sorry? Yeah.
Meaning creating the route?
Yeah, we're going to go ahead and well, we're going to go ahead and manage some of the responses, as I feel like the best way to visualize it.
Okay.
This equals 1. Go ahead and try. And then if the response request post. So we're using that response there. And then this is assuming that if call was successful, if response.status, and we're just going to break. And then this is where we actually go ahead and place that sort of safeguard response.status for the QPS.
I think it's 400 something.
Yeah, 403.
403. Or different than 200, you can put.
Yeah, exactly. I mean, you can do different than 200, but I think that we're going to actually account for that. And we're also going to, so then we're just going to sleep. One.
No, don't put to sleep.
And then, let's see, we're actually going to do one more. Except. Then we're going to print an exception. And we're also going to stop after 4 attempts.
Oh.
So if n is greater than 4, we're just going to break. And then this is the portion of like return, none of the call was not successful, and how we format that return down here, because it's very long.
I see.
And then we'll go ahead and print out how long the route will take. Let's see.
So I can see the response is getting in a JSON format. That's why we're getting the brackets for the field that I want, the routes. Check the first route, of course. Check the summary. In the summary, we usually have the traffic delay in seconds, the travel time, the ETA calculations, and the distance as well. But we don't use it in this case. And then the response we have usually you separate the routes in different an array of legs. Yeah, depending on the stops that you have to. So we are assuming that we're going to get at least one leg. Yeah. That's correct. And the points, the lat and longs of these points.
Yeah, the leg and being one route at minimum, like just the whole route.
Yes.
Yeah.
Yeah, and then you get the points. Get points of the leg, and that's it.
Yeah.
I think you should display that.
Here we go. And now we see the slightly different route, actually, so it ran that time. I'm guessing there was...
Where is it?
Oh, down here. So here we can actually see, so I went ahead, as like an editor's note, I went ahead, sometimes it does happen, like I've noticed indentation errors with that, so I went ahead and used some of the sample code, and went ahead and, because the indentation I feel like in Jupyter is a little bit finicky, but anyway, you can actually see here the original polyline, and then you can see the route drawn on top of it.
They're not the same.
Exactly. They're a little bit different, because the idea is to actually take the route and run it through the same coordinates and see, you can actually see the difference a little bit between the polyline and the TomTom route.
This tells me that this case, the driver actually follow the fastest route in this case.
So here we can actually see, so the fastest route is the red one. It does show, so you can't see it, but it does have the original reconstructed route supposed to be black. And the original route from the taxi driver is the blue one.
Okay.
And also,
can you zoom in a little bit? Yes. Can you zoom in a little bit in the map to see the route?
Yeah, so we can go ahead and
the route comparison.
Yeah, so you can actually go ahead and see here that it looks largely the same, because here you can actually see is that that's not a road, because there are a little bit of like discrepancies. So it seems like this is probably the same route, which will often happen, most likely. This is where we're going to go ahead and add in some of the travel times, actually. So this is where we'll start setting up our calculations for the fastest routes and things like that. So we have the fastest travel time here, and then we're going to give the travel time of the taxi route. Always wary of the indentation.
Yeah.
Since it gave me issues. We're going to go ahead and this is going to be largely the same. We're just going to change it where this is false is actually going to be. Let's go ahead and see here. So we have the polyline, and then here we're going to go ahead and add the departure line.
Yeah.
We're going to go ahead and indent
also after the append in
this
the other
section.
line.
Yeah,
Sounds interesting.
something. Let's see what happens. See, it does not like the results.
No. Unexpected indent.
Now we have the unexpected indent here. There we go.
Okay, what it's doing now is to, in the loop mode, taking a random sample for the random sample
So
of the
here we
whole
have the
list
random
that you
state
have.
123, and then I put the sample as 300 just to make it a round number.
Yeah, and then you took into two presented the two values, which is the route calculated by us, by the routing API, and the route that the sample provides.
Yeah.
Then you add it to the list.
And while that's calculating, I'm going to go ahead and add some of the calculations down here. So we're going to go ahead and calculate the difference in minutes between the two routes results. And then these are going to look largely the same from line to line.
Okay.
Equals results taxi travel time minus results fastest, which is hopefully pretty self-explanatory as well. And then we're going to go ahead and divide that by 60. And then here we can actually reuse this to calculate the relative difference, except we're just going to change this to relative diff. And then we're going to go ahead and just divide it by, instead of 60, we're going to go ahead and divide it by results. And then here, we're going to go ahead and just keep, we're just going to go ahead and keep the trips that are long enough for our results to kind of be within the same range. Results, which looks a little counterintuitive.
You want to remove?
We're going to remove super
results,
short trips. Like trips should take at least 1 minute, basically, is what we're going to add here.
Okay.
Trips should be 1 min or longer. I couldn't decide between more or longer. And then we'll go ahead and display the results. So now this is done running. We're going to go ahead and try and run episode 17, doing our tutorial. And that's a maximum relative difference is 9.3.
This is the value, maximum value between all the relative diffs.
Yeah, the maximum, the largest of all the relative differences. And then I want to see if this will work, because in the tutorial we have a little bit of histogram work, but I don't think the values translate over. They might. I can go ahead and add it in and explain. And so here actually from that we can go ahead and you can see the relative difference here in the visualization, so you can actually go and see where some of them, where the relative delay is. And so what we're going to go ahead and see is we can show the points where the taxi trip started with the corresponding delay then counted along the way. So yeah, as I suspected, this is where the trip started. So you can actually see here that this is where we draw it.
Because, so these dots are representation when the trip starts, and depending on the color, it says very low delay or not much delay
Exactly.
or right on top.
And if we were to
Greens
do a
are
histogram, like we kind of did at the beginning, you can see that most of them don't have a lot of delay, and some of them have a lot of delay. And that can be due to different things. I mean, we're also we have certain, I think, ramifications on our sample. We're taking a certain number of the trips as well. We're taking a random sample, and we're performing some of the calculations on that. And then the fun one that I think also draws it even better.
This is super nice.
I have some free text here that's happening.
Can see
some error text
on this.
There we go. Yeah.
Okay.
I had some free floating text, which is obviously not Python. But in here you can see them as well. So like over here in the tutorial, we also see.
Whoa! Slow down. What is this?
So this actually shows the taxi traces with the corresponding delay, like you see it shown here. So this is how the tutorial explains it. And here, when we go ahead and run it right now, you can see some of them looking a little bit similar. So this is actually showing the traces themselves.
Yeah. Okay. From the whole routes of each one.
Yeah, from the whole trip.
Is this a function from volume as well? Like a layer that you put on top?
So interesting.
Can I just check
we
that?
are just because I know
it's a polyline. Yeah.
It's a polyline. Yeah. So we're redrawing the polylines in different colors.
Okay.
Yeah, exactly. So we see. And then if you go actually over here, at the time, like, of course, there were some conclusions at the time of writing that, for this data set, some of them were, would be shorter if they use TomTom, et cetera, which was, you can actually go and form your own conclusions. You can also use a different data set. I suppose you might have to do some reformatting, but since this is written for this particular data set, but you could theoretically do something similar with a different data set, right? And as long as you're able to build the polylines and do it somewhere else too.
So visually, I can see there are lots of green.
Yeah.
So I imagine taxis actually follow their fastest route.
The fastest.
Now imagine if it's not taxis, maybe delivery vans of your fleet of trucks that you want to use also for transportation. You can see and calculate if you already have the data of where they move to. We can analyze if they're actually following the route that is assigned to them, etc.
Exactly,
like
and because we're doing the reconstruction as well, I imagine you could actually say if you had a CSV of like fleet trips, you can actually build out. And you could do this and say, hey, are they taking extra stops? You could even add the geofencing aspect, like, that we've done in previous streams. Or are they lingering in an area where they otherwise wouldn't be, or something like that, right? Because you're using some of the reconstruction, but you're also visualizing the delays here. So is it getting a traffic delay? Are they just taking an altogether different route? Like what's happening is a really good one for like on demand, also for fleets. Yeah.
So is this in a GitHub repo? How people can get this?
We're gonna put it in a repo, and then we will link it. Especially when this is on YouTube, we'll also put the link in the description. Well,
this has been a very learning experience for me. Thank you much, Olivia.
Thanks,
I wouldn't know how to start with this.
Well, happy mapping to everyone watching this on Twitch or YouTube, and hopefully we see more Python and data science on here soon.